Assalamualaikum and hi, it's me again, Miss Huda. Let's proceed to example number 3. Determine the reaction at the support A and B of the overhanging beam. Then draw the shear force and bending moment diagram. The difference between example 1 and example 2 with this example 3, this is overhanging beam. Example 1, example 2 are the simply supported beam. For this example, I will show both graphical method and sectional cut method. First, kita akan dapatkan reaction dulu. Since at A, it is pin support and at B, it is roller. Therefore, the free body diagram shows that A, there is a reaction arah Y and there is a reaction arah X. How about B? It is a roller support, meaning the reaction only arah Y. We can start with finding the value of RAX. And since there is no force horizontally, meaning that the RAX is equal to 0. Next, we can find the value of RAY by taking moment at point B. Total moment at B equal to 0. We have one force loading 10 kilonewton going to the B, meaning that it is counterclockwise, negative 10 kilonewton times the distance here is 9 meter. Next, we have the reaction RAY going to B times 7 meter distance. It is clockwise, therefore positive. Another loading here, 24 kilonewton counterclockwise, therefore negative. 24 kilonewton times the distance is 3 meter. We also have 15 kilonewton going to B. It is clockwise, therefore plus 15 kilonewton and the distance is 3 meter. Equal to 0. You can get the value of RAY 16.714 kilonewton. Next, we're going to get the value of RBY. Since our RAX 0, RAY is 16.174 kilonewton. Then value dia positive. Meaning betul lah our assumption dia memang naik ke atas. First, I have force 10 kilonewton going down. Therefore, negative 10 kilonewton. We have RAY, which is 16.174. Tak apa, later kita akan replace. Then, we have the negative 24 kilonewton here going down. So, negative minus. And we have RBY going up. Kita assume dia arah atas. And lastly, we have 15 kilonewton the loading. Going down, minus 15 kilonewton. Okay, ini typo. Padam ya. Equal to 0. We can solve this. 10 minus 24 kilonewton minus 15 kilonewton. Then you will get negative 49 kilonewton. Which means that when we replace the RAY, we can get the value of RBY, which is 32.286. Next, we can draw the shear force and bending moment diagram using the graphical method. As usual, you need to draw the line at each point along the length of the beam that has force, reactions, or loading. Sama je semua tu. We have here at 10 kilonewton, at the RA, at the 24, at the RB, and at 15 kilonewton. Therefore, we have 5 lines. We're going to start to draw from the very left. Okay, sama saja. SFD and BMD line. Right, for the first one, we look at the very far left here. It is 10 kilonewton force going down, meaning that Daripada kosong, you akan gerakkan dia ke 10 kilonewton. Maksudnya sebab dia turun ke bawah, so kosong minus 10. You get negative 10. Next, there is no force along 2 meter of the overhanging beam. So dia akan go straight for the SFD. And you will see there is a 16.714 kilonewton force or reaction, RA going up. So plus sebab dia naik ke atas, negative 10 plus 16.714, then we get 6.714. Next, there is no force at all for the next 4 meter. Therefore, straight sahaja. Then, after that 4 meter, you see there is a 24 kilonewton force turun ke bawah, meaning you have to minus with 24. 6.714 minus 24, you will get 17.286. So, dia akan turun bawah. And for the next 3 meter, there is no force, so it goes straight. The RBY 32.286 going up. Therefore, 17.286, this is value ni negative plus 32.286. It become 15. Naik ke atas. After that, there is no force for the last 3 meter itu, so go straight. And after that, last kali we have the force at the overhanging beam there. It is 15 kilonewton, meaning 15 minus 15, it will come back to 0 here. So this is the overall SFD. Next, we're going to calculate for BMD. The method masih sama by calculating the area. We have area 1, area 2, area 3, and area number 4. For area 1, we have negative 10 kilonewton and the width is 2 meter. Therefore, area 1 is equal to 2 meter times negative 10 kilonewton. It is negative 20 kilonewton. For area 2, rectangle, it is positive 6.174 kilonewton and the width is 4 meter. Therefore, area 2 is equal to 6.174 kilonewton times 4 meter. 24.696. Area number 3. It is negative 17.286 and the width it is 3 meter. Therefore, area 3 is negative 17.286 kilonewton times with 3 meter. 51.858 kilonewton meter. For area number 4, the width is 3 meter and the height is 15. Therefore, area 4 is 3 meter times 15 kilonewton. You will get 45 kilonewton meter. So we can start to draw the BMD. Must start dengan kosong So here, we don't see any moment yang memang ada, like example number 2, tak ada. All force here hanyalah point load. Therefore, kita akan just look at the first area, area number 1. Untuk kita draw dekat line nombor 2. And in this case, area number 1 is negative 20. Therefore, I put it down here. You can put negative also, never mind. Next, for area number 2, I just realized that I calculated a bit salah dekat sini. If you notice that this is 6.714, not 174. 714. 26.856. This one, don't forget negative. First area, it is negative 20. Okay, so kita sambung on area number 2. It is positive 26.856. So negative 20 plus 26.856, it becomes 6.856. The area number 3, it is negative 51.858. Therefore, 6.856 minus 51.858. You will get 45. Actually, it is 45.002. But since kita ada round up sebelum ni, bila kita calculate for reaction, that's why kita terdapat tepat-tepat 45. Last kali, the area number 4. Value dia adalah positive 45. Over here, this is negative 45. So, kita plus lah dengan that 45. Dia come back to 0. Okay, siaplah SFD and BMD for the graphical method. And we need to calculate the maximum shear force. So, maximum shear force is basically, where is the highest number? This one, yeah, 17.286. And for bending moment, it is 45 kilonewton meter. Next, kita akan kira SFD and BMD juga, but for the sectional cut method. Find the reaction, as usual, the same method, which is finally we get the RAX kosong, RAY 16.714 and RBY 32.286. Then we're going to cut it into sections so that we can get the value of V and M for each section. So for the first section, before the reaction, kita akan cut dekat sini. So since this is at this point ni A and ini B, so ini I name it as C. And another one, before the 24 kilonewton going down to, this is D. And then before the reaction at B, so ini E. And last sekali di sini, before 15 kilonewton force to F. Okay, look at the section yang saya put sampai C. That's the first one. And the boundary is X must be bigger or equal to 0 meter, but must be less or equal to 2 meter. So we have the reaction from the cut, which are the shear force and the moment. Total moment Fy equal to 0. So kita akan start dengan force equation. 10 kilonewton turun ke bawah, it become negative 10 kilonewton. Stick to V mesti going down and moment mesti counterclockwise, yeah. That is the reaction once kita cut in section. Therefore, minus V equal to 0. So, V adalah negative 10 kilonewton. And to get the value for moment, we take moment at C, negative 10 counterclockwise. That's why negative 10 kilonewton here. Next, the distance is X meter to C. And for the moment, it is counterclockwise. Negative M equal to 0 and M is equal to negative 10X kilonewton meter. For the next section, we're going to look at D. It is over here. So for D, we will include reaction at RAY itu. So the boundary is going to be from 2 sampai 6 meter. 0, 2, 6. So sampai sini lah. That's why X must be bigger or equal to 2 meter but must be less or equal to 6 meter. Total Fy equal to 0. Negative 10 kilonewton ini referring to this one. It is downward force, meaning negative 10 kilonewton. And then you have the reaction going upward Therefore, it is plus 16.714. And we have the shear force V going down, meaning jadi negative V. And you can simplify, you get the value of V positive 6.714. Next, we're going to take moment at D, negative 10 kilonewton, which is the force here going to D. The distance going to be 6 meter and negative because of counterclockwise. And you have the reaction at A, which is 16.714 ni. Pergi ke D, this is clockwise. That's why the positive here. And the distance is going to be distance ini. So maksudnya X meter tolak 2 meter. This one, yeah. Next, we have the M itself, which is the reaction of our section tu. Kita cut dia, so reaction dia keluarlah that M. And it is counterclockwise, negative M. Then we can simplify everything. You get M equal to 6.714 X kilonewton meter minus 32.428 kilonewton meter. Next section, kita akan tengok di sini. Cut dia, so DE. Alright, so this is the one yang saya dah lukis elok-elok lah. Saya dah potong our sectional cut. So the one that I cut is here, E. The boundary is from here to here. Okay. So dari sini kosong sampai sini tu 6. Ini adalah 9. Therefore, X must be bigger or equal to 6 and must be less or equal to 9 meter. Total force Fy equal to 0. We have one force or loading 10 kilonewton turun ke bawah. That's why the negative. We have the reaction going up, positive 16.714. Another loading turun ke bawah, minus lah 24. And we have the reaction of V turun ke bawah, negative V equal to 0. So V is 17.286 kilonewton. And then we're going to find the value for moment. Moment we're going to take at E. So 10 kilonewton pergi ke E. The distance going to be X meter. It is counterclockwise, that's why negative. And we have 16.714 going to E. It is clockwise, positive. And the distance going to be X meter minus 2 meter because of the distance is from di sini sampai sini. So kalau ini ke sini adalah 2 meter, therefore X meter minus 2 meter. And next we have that 24 kilonewton pergi ke E, counterclockwise. That's why negative. And the distance here, we have to minus X meter minus 6 meter because of the distance from here to here adalah 6 meter. Okay, ini panjang ni 6 meter ni. Right, and the distance sampai sini adalah X meter. So balance dekat sini adalah X minus 6. Or X meter minus 6 meter. That's why jadi macam ini. Okay. So simplifykan everything. 16.714 darab X meter jadi ini. 16.714 darab dengan negatif 2 meter jadi negatif 33.428 kilonewton meter. Next we have the negative 24 kilonewton times X meter. It becomes negative 24 X kilonewton meter. And then negative 24 kilonewton times with negative 6 meter. Then it become positive 144 kilonewton meter. this one. Then you can calculate everything. You get this as the value for moment. Right, are we done? Not yet. We have another one, which is we're going to cut it here. This is F. Paling last lah ni. Okay. So, the boundary is going to be X must be bigger or equal to 9 meter. Right, sebab ini 9 meter. Okay, sampai sini 12. Jadi, X mesti lebih besar atau sama dengan 9 meter. Dan X adalah kurang atau sama dengan 12 meter. Total force arah Y equal to 0. Okay. So, kita akan tengok negatif 10 turun ke bawah. Sebab dia turun ke bawah So, that's why dia negatif 10. Plus 16.714, the reaction of REY is going upward. Jadi positive 16.714. And we have one load 24 kilonewton turun ke bawah negative 24. And we have 32.286 force ataupun reaction RVY naik ke atas, so plus 32.286. And last but not least is the V, shear force turun ke bawah, so negative V sama dengan kosong. Then we can solve it and get the value of V 15 kilonewton. And for moment, sebab kita nak dapatkan berapa M ini, we have force which is 10 kilonewton pergi ke F. It is counterclockwise and distance dia adalah X meter. Negative sebab counterclockwise. Then we have 16.714 which is the RAY. It is clockwise, positive, and the distance is, okay. So kalau di sini 2 meter, panjang ini 2 meter. Therefore X minus 2. So X meter minus 2 meter. Next, we have the 24 kilonewton. It is counterclockwise, negative, and the distance is going to be, okay, dari sini sampai this point, it is 6 meter. So X minus dengan 6 meter. Next, we have the RBY or 32.286. This is clockwise, jadi positive. And the distance is from here sampai ke kosong. Ini adalah 9 meter. Meaning that X minus 9 meter. The distance. And last kali adalah M, which is counterclockwise, so negative M equal to 0. Dan you can calculate semua, you akan dapat M adalah, sorry saya typo lagi, ni padam which is this one is the correct one. What we do next is we have to record this value so that senang kita nak lukis the shear force and bending moment diagram. This is the first section, which is X must be bigger or equal to 0 meter but less than or equal to 2 meter. Next, for this boundary, the V, the M. For this boundary, the V and take the M. And last, this one, V and M. We can draw the shear force and bending moment, right? Draw the 5 lines and SFD and PMD line. So we're going to do the first boundary, which is X is bigger or equal to 10 meter but less or equal to 2 meter. We get the V is negative 10. Meaning along 0 sampai 2 meter itu, V dia adalah negatif 10. You can write negative here also, tak kisah, or you boleh draw macam ini. Positif, negatif. After that, for the next 2 meter tu memang sepanjang 2 meter tu So buat je garisan. Next boundary, X must be bigger or equal to 2 meter and less or equal to 6 meter. We get the V is 6.714. Meaning dekat atas tu lah, positif value-nya duduk atas. So sepanjang dari 2 meter dari sini sampai sini, dia go straight line ya. For the next boundary, X must be bigger or equal to 6 meter and X less or equal to 9 meter. The value of V is 17.286. Sorry ya, saya typo kat sini. It is negative 17.286. Let's check balik. Ada kesilapan sikit di belakang. Di sini ya. So if you notice kat sini saya typo ni. So saya dah betulkan. Should be your handout dah betul lah. Value dia adalah negative 17.286. Next, for the 3 meter memang daripada 6 sampai 9 meter value dia itulah dia negative 17, therefore straight line lah. For 9 meter up until 12 meter, V adalah 15 meter, meaning that along that 3 meter tu 9 sampai 12, V dia memang 15 kilonewton. Therefore straight juga. So this is our SFD. And for BMD, we look at the first boundary, M equal to negative 10x kilonewton meter. So kita akan buat untuk X sama dengan kosong. So kalau X sama dengan kosong, meaning dia akan jadi kosong lah. So kat sini value dia kosong. And bila X sama dengan 2, the next boundary. So negatif 10 tukar X ni jadi 2. Negatif 20 kilonewton meter. Therefore negatif ya kat sini. That's why dia turun bawah like this. For the next boundary, X must be bigger or equal to 2 meter but less or equal to 6 meter. M is 6.714 X kilonewton meter minus 33.428. So kita akan check dulu dekat X sama dengan 2 meter. Masukkan saja. Therefore, X sama dengan 2. M sama dengan 6.714 darab 2 kilonewton meter minus 33.428 kilonewton meter. The answer is still negative 20 kilonewton meter. Meaning that dia memang nombor dekat sini lah. Tak pergi mana-mana Tak ada naik atas, tak turun bawah. And next boundary dia adalah 6 meter. So X sama dengan 6 meter. M equal to 6.714 darab 6 kilonewton meter minus 33.428 kilonewton meter. 6.856 value dia positif. For this boundary, value dia dekat 6 meter adalah positif 6.856. So dia akan go straight naik atas macam tu. Next boundary we have here, X must be bigger or equal to 6 meter but less or equal to 9 meter. Sama juga, so you akan masukkan 6 meter as the boundary kat X ni, replace. I get the value is, sorry again, dekat sini sebenarnya plus ya, saya typo ni. And check juga dekat belakang ni, should be dia pun sama plus ya. I think I typo but never mind, dalam handout what saya betulkan. This one is supposed to be tambah. Ini pun sama, saya baru betulkan ya. So kalau you dah replace dia dengan 6 meter here, then you akan dapat value dia 6.856 juga. Untuk X sama dengan 6 meter. Okay, and do the same for X sama dengan 9 meter. Dapat 45. So, X sama dengan 6 kat sini saya dapat 6.856 kilonewton meter. When X sama dengan 9, I get the M is 45.002 kilonewton meter. Basically kita tahu kenapa dia ada 0.002 tu since kita ada round up masa kita kira reaction. That's why value dia tak tepat 45. Supposedly dia tepat 45 sebab value ni negatif sebenarnya. So dia turun bawah. Dan last kali untuk this boundary M equal to 15x kilonewton meter minus 180.002 kilonewton meter. Okay, so X replace lah dengan 9 meter. Okay, ganti dengan 9 di sini. Okay, X sama dengan 9. M sama dengan negative 45.002. Okay. Tapi saya ambil dia 45, okay, which is true. So, sama bila X sama dengan 9 meter. And bila X sama dengan 12, so replace 12 kat sini. So, X sama dengan 12. M sama dengan berapa? So, I kira I dapat negative 0.002. It's very small. So, kita anggap dia kosong lah kat sini. Beza dia tak besar. It's like dah lah 3 decimal places sampai 0.002. So actually dia kosong lah sebenarnya. Sebab kita ada round up ataupun round down masa kita kira reaction. That's why kita tak dapat tepat-tepat. Siaplah our sectional cut method. And we can get the maximum shear force, which is 17.286 kilonewton. And the maximum bending moment is 45 kilonewton meter. Siaplah our example 3. Thank you.